in this point, I would like to say that hierarchical methods constitute C classes of n observations. And the difference to non-hierarchical one is that the non-hierarchical methods are based on assigning the observation to earlier known number of clusters. But how hierarchical approaches may be realized? There are different methods to realize hierarchical approach. Some of them are indicated here in the slide. And also the most important information is that hierarchical may be realized in two ways. I mean, it will be agglomeration or diverse technique. If we consider agglomeration, uh, when we start our approach from dividing all the data into single elements and then just connect them from one to one to make the groups which are similar up to the moment in which we have all data in one group. But the difference between diverse techniques is that firstly, we have the all data in one group, and then we just divide this into plenty of groups that will be finally that each data is a different group. Today in my presentation, I would like to focus on the VARC method, which is based on the measurement of dissimilarity between two clusters that are represented by the sum of square of deviation inside each cluster. How does the VARC algorithm looks like? It's presented here in the cluster, in this slide, and also I would like to say that initially we start the agglomeration cluster analysis division into M cluster from M data. So as I mentioned, firstly, we have all data separately and then calculating distance between each pair of cluster, creating a symmetrical D matrix consisting of distance. And then we look for the cluster for which the distance between two objects is the smallest one. And then we create the moment in which these two values are connected to one cluster. And then we update the calculation. And finally, we check is the moment that we stop, I mean, all the data are connected into one cluster. If yes, we just finish our method. Okay. So now let's move to non-hierarchical methods. They also may be different, like Kamin, Comedian, ITM, or self-organizing maps. But today I would like to focus on Kamin algorithm, which general aim is to find the extreme of objective function. The equation, how to realize it, is presented on the slide. And in this place, I would like to pay more attention on the distance of measure. I mean, how we calculate that the data that are connected into one cluster are similar. What is the value that they are connected in one place? Here, I would like to say that if we consider the size of the matrix, if we have plenty of input parameters, the size of the matrix is increasing really quickly. So what measure of distance are indicated? Of course, the first and the most common is Euclidean distance, which is presented here in slide. But I would like also mention that there are more distances, and always when we start cluster analysis, we have to consider what is our most important aim. Do we look for something like to make a strong connection that the data are similar and we don't care about the data that are sit dramatically from the others, because look, if we consider the group of the data in which only one value is much higher than other, in Euclidean distance, it will be not so easy to find. But for example, if we use the Chebyshev distance, I mean, we have, I don't know, 4 or 5 parameters, and the measure of distance in Euclidean will be calculated like the distance between each value separately and then recalculated. In Chebyshev, the if the one of the parameter is exceeding each other, the Chebyshev will be good to increase that during that, at least in one feature, there is a huge change. So let's make this distance the most important during the classification of our data. So in this point, one more time, I would like to say it's very important to consider which measure of distance we should use. Okay, in this point, I just make a short introduction that just concerns what is the data mining, why data mining, what are the main data mining techniques. If anybody would be interested more in this topic, there are plenty of publication, plenty of information where you can find exactly what are the algorithms. But in this point, I would like to make this introduction like, okay, this is the problem and how to apply the problem and solution of data mining to a real life problem. And today I would like to present the application of data mining to the problem of power quality, uh, and why power quality according to me is very important problem, because it is it's strictly connected with the electricity. And could you imagine the situation that our present world is without the electricity? It's really hard to imagine. And I think that we cannot say that our future can be without renewable energy sources. And the good question is, what is the impact of these renewable energy sources to the grid? And here, imagine that we have plenty of points that we analyzed in the same moment, and we just analyze it for long time just to find the impact of the sources. So I think using data mining would be really useful to gain knowledge about this. So that's why I decided during my research to apply data mining to electricity problem. The input parameters are connected with power quality. The power quality just inform us that for us as a casual users of energy, that the energy is sufficient. I mean, if there is no electricity, there is a problem for us. But in fact, nowadays the energy is some kind of the product. So it has a lot of features that describe this electricity, and that's why I focus on the power quality indicators. So just for the general knowledge, what is the power quality? I would like to say that this power quality disturbances may be divided into 2 groups. The first groups is are connected with the slow changes. I mean, all of us know that there is a value of voltage in our sockets, and it just is, and we know that it's always on the similar value. Of course, it's changed in some way, but in fact the parameters are given: the frequency, voltage value, all voltage fluctuations, and similar parameters. For those who are interested more, there are harmonics, interharmonics. So this part are connected with the data that describe in long term. But also there are some short time problems that are called events. that for us the most important events are interruptions in delivering of the